This lecture is about compounds and moles. These problems are done exactly as the ones that we lectured about with elements. There's just one more step that you have to do. We learned in the last lecture that a mole of any element is equal to its atomic mass. And the difference is, how do you determine the atomic mass for a compound? Well, it's called something a little bit different, called molar masses, because it is composed of more than one element. So therefore, you're going to have to calculate these. The definition of the molar mass is the mass in grams of 1 mole of a compound. 1 mole of a compound will be equal to its molar mass. Let's take a look at, to be able to calculate the molar mass of a compound, let's take a look at how to do sugar. You're going to determine how many of each element are found within the compound and multiply it by the atomic mass of each of those elements. So within the sugar molecule, I'll have 12 carbons, 22 hydrogens, and 12 oxygens. I will use the periodic table to look at the atomic mass of what a carbon is, hydrogen, and oxygen. Multiplying that going straight across, you'll find what each element contributes to the molar mass of the compound. So 144 grams comes directly from having carbon within this compound, while 192 grams comes from oxygen. Once you add up each of the elements total contributing to this compound, you'll find that the molar mass of sugar is 358.12 grams. Let's calculate the molar mass of aluminum sulfate. Again, you're going to start determining how many of each of the elements reside in this compound. You're going to look at the subscripts. There's 2 oxygens, and in these parentheses, it's 3 times 1 sulfur, and therefore, to find out how many oxygens, it's 3 times 4, 12 oxygens. Again, you're going to look up each of the atomic masses for the elements, multiply it straight across, and then add up these columns. This is the total for the molar mass of aluminum sulfate. When using that in a actual equation or actual compound, again, you need a numerator and a denominator. Remember, we're trying to come up with our own conversion factors, and these are conversion factors that deal with compounds. Let's determine the molar mass of calcium dihydrogen phosphate. Again, determine how many each of these elements reside in here. These parentheses only involve the elements within here. So I only have 1 calcium and I have 4 hydrogens. Remember, 2 times 2. That means then I will have 2 phosphoruses, 2 times 1, and oxygens I will have 8. Multiply again each of those by their atomic masses off the periodic table. When you add that up, this is the total for the molar mass of this compound. So 1 mole of any compound is equal to its molar mass. Again, writing this in a type of a format that you would see being used in a problem. Mole conversion factors. We had developed 2 of them from the previous lecture that deal with the elements. The compounds are basically identical. There's just an extra step. Notice 1 and 3 are basically the same, except talking about a compound here. On the compounds, you're going to have to calculate the molar masses, while when it's just a single element, you could find that mass off the periodic table. Rule number 4 states that a mole of any compound also has this many atoms in the compound. And how that looks, written again as a numerator and denominator, is such. A mole of any compound is equal to its molar mass, rule number 3, and this is rule number 4. Let's solve the problem here. Start with what you're given. If it's not in moles, get it to mole. It's the same mantra that I say when they're elements. Here, to get it into moles, these are the 2 rules that you're going to use. A mole of any compound is equal to its molar mass. A mole of any compound is equal to Avogadro's number. Again, you're going to put it into the problem so that the words with the substance cancel out. When I do that, I will have moles of aluminum sulfate up here, and it's asking for atoms, so I'll have to add the rule number 4 on here. And when I calculate it using my calculator, this is the answer that I get. They want to know how many moles are contained in this many atoms of calcium hydrogen phosphate. dihydrogen phosphate. Again, if it's not in moles, get it to moles. These are the two rules that you're using. I notice that I can take rule number 4 and say this many atoms is equal to 1 mole of the compound, and I automatically get my answer. So I don't always have to calculate the molar mass of the compound. Make sure again that you work this problem because it has a scientific notation in the denominator. You need to put parentheses around it, and make sure that you realize when you do that it's a negative 11, because remember it's a minusing effect. 13 minus 23 is about a negative 11. That's how you can check.